is March 11th, 2025, and this is the bi-weekly libhal meeting. Last week, we skipped a meeting. I was just due to time, but this week, we are following up. All right, so the agenda. So a few things we're gonna go over. Supporting clang-tidy in all builds, something we haven't really had support for, and I'll talk about that in a sec. The work that's being done on clangd and clangd-tidy, which is some foreshadowing for what we're gonna talk about next. Detecting resource exhaustion and contention. We'll also talk about stack-only applications and also about relaxing ABI stability of platform packages. And actually, this also includes board packages. I was going to go over the design of peripheral managers, but I'm continuing to do work on them and trying to justify if they make the most sense. Oh, and for the most part, everything about libhal 5.0 has been figured out. And we're just not going to go over I2C target. I spent some time thinking about how I want to do it, and I have some ideas, but I don't have anything concrete, so we're probably not going to go over that last item. Most of the things have been backported into libhal, except for making hertz integers rather than being floats, and also all of the callback APIs, all of the timeouts and stuff like that, and callbacks should have some sort of tag. None of them have tags, therefore, mostly because that would be a ABI break, and yeah, that's pretty much it. I'm thinking about adding in the tagged versions and then having the implementations just use variants between the two, just to kind of be a stopgap before as we get things set up, but we'll see. All right, so let's get on with what we have for today. So supporting clangd in all builds. So here's the current problem. Sorry, clang-tidy in all builds. Clang-tidy will produce an error when you try to execute with CMake, and I should have kind of removed that period, but it happens right now when you try to use the ARM GCC compiler. So if you have built anything with libhal demos or whatever, if you look at the CMake output, you will see that it says that skipping clang-tidy because we're doing a cross build. This is a comment that I put in there just because it wasn't working otherwise. We also skip clang-tidy if we're using it on Windows. And this, I forget why Windows has issues with it, but I remember that being an issue. I reactivated it today just to see what issues will come up. And you get a whole spam of different errors, but usually there are a whole bunch of the same error, unsupported argument, Cortex M3, and MCPU, and that gives you a listing of the processors that are supported. This is an issue. And it doesn't just happen with just this command. I can move this command around to see if any of the other commands will fault it first. And yeah, whatever is the first command or first argument in my compile expression that gets past the clang-tidy, anything that is not something that clang or clang-tidy understands will cause an error. There's this thing called extra arguments that you can supply as well. Those work, but it's really annoying and also not really feasible to know at build time which flags will or will not work with clang. So that's a bit of an issue. So I've just overall just disabled it, which makes builds faster, but also means that people, when they try to make PRs, will get more errors than they normally would. You can get around this by just doing a Conan build dot, which will build on your machine. If you're using Windows, though, that will not work. I keep forgetting this, and when people are doing development on Windows, they ask me, how do I make the same output happen? And I tell them there's not really a way, at least not yet. Not yet, at least. So one of the things that I observed was that clangd also supports clang-tidy checks. It will observe the clang-tidy configuration file, the configuration YAML file. And clangd mostly works fine with our cross compiler. There's like a slight issue with system headers, which I'll go over in a little bit. But ignoring that problem, it pretty much works flawlessly, even with all of our different command line arguments that don't work with clang. So what I ended up discovering is that clangd does the work of sanitizing the arguments that it doesn't understand, or that clang or clang-tidy doesn't understand, in order to make sure that it always works. clangd tries to work with as many different compilers as possible. Still with the clang backend, or the clang compiler doing all the hard work. but they do a lot to make sure that the information they get from the compile commands.json file, whatever's in there, still works with Clang. So there was a solution that came up in r/cpp where some folks had made this thing called the clangd-tidy. It's basically using clangd in order to perform clang-tidy checks, as well as also to run certain types of checks that only clangd supports. This I love. Now I think clang-tidy supports this. I could be wrong here. But I know clangd for a fact supports out of the box by default include what you use. That particular feature allows us to see little yellow squiggly lines saying, hey, you have an include header that you're not actually using. Wouldn't it be really cool if at compile time you got these warnings? Wouldn't it be really nice if not only did you see this in Clang in your IDE, but you also got to see this in your PR, so that our PRs can make our code cleaner? So there's a program called clangd-tidy, which basically operates just like clangd, uses clangd to do all of its work, and with a little bit of fixes and patches to clangd and also some patches to clangd-tidy, it was able to work with the ARM cross-compiler flawlessly. Just does it. And also because clangd is a little bit faster, it turns off certain checks that clang-tidy would normally do that a little bit longer. Because it skips a lot of those, and I don't think we're using any of those either, I don't think, it makes it so that our builds, when we actually do normal builds, are basically faster. So we end up having faster builds. Now, I may want to bring back those clang-tidy checks. And if I do, it'll probably only be for Linux, just because Linux on the continuous integration on GitHub Actions boots up as like one of the fastest operating systems. So we can do the deeper checks on Linux, and then for Mac and everything else, basically everything else, we'll just follow up with the clangd checks. And this will probably be a built-in aspect to sclang. Regardless of how we develop it, I think that having these type of checks, so long as they're relatively fast, should be built into what the compiler gives you. I think people would love that. All right, so let's go into some of the work that I've done in order to enable this. So one of the things that I did recently was add in the built-in headers flag to the config file for clangd. And then here's me updating the documentation. And then here's the documentation that I added. So this will kind of explain what the built-in headers does. So it controls whether clangd should include its own built-in headers like standard def or use the system headers found from the query driver. When we use clangd, the query driver regular expression basically will search and figure out if the first argument, basically the command in your command line, is your compiler. And if it is your compiler, and it fits the matching numbers, it'll start executing with certain types of commands. It'll figure out, oh, is this GCC? Yes, it is. Okay, cool. Let's give it these certain sets of commands to get out the system headers and maybe some other information about the compiler itself and what it can target. Now, that can be used to gather quite a few headers, but the header that gets removed is actually the system header. And by default with clangd, apparently back in the past, from the messages I saw online, I think it was like 2018, they made a change that before it would use the query driver's system headers, but then that caused some issues. So they moved it over to Clang's headers because they knew that they'd always be available. But that caused a particular issue for us, which is you basically see at the first include header, no thread API. This is basically a Clang, this is basically an issue with the Clang headers needing certain types of APIs or certain types of macros defined. Now that I know that it's a Clang specific thing, I feel more comfortable at least adding in those defines just as a stopgap so we can work on adding in clang-tidy now versus waiting for this to be added into the latest version of Clang. Currently, it only comes out in Clang D21, and I think the latest version of Clang, or LLVM, is 20. So we have another release we have to wait for before we get this available. But in the meantime, if I add in those defines, those macros, it should fix it. But basically, the idea here is that you can switch between clangd and query driver. So you can say, hey, I want the clangd system headers just because those make my life a little easier, and then stick with clangd, which is also the default. So if you don't include it, it does that by default. If you want to specifically use the query driver's headers, you can then specify query driver. And yeah. And then also in the clangd-tidy project, I also added in query driver support because it didn't have it before, meaning that it would not work with the ARM compiler. But now it does. So yeah, so that was that. Now we're on to detecting resource exhaustion and contention. Here's an idea that I've been rolling around with, and I've been working on a PR force. Basically the approach is to make power on and configure pin throw an exception. Basically, think of power on as a using the power on bit or the power on information as a lock, basically. So if one of the registers for the power on bit for a particular peripheral is on when another driver tries to come in to power on that same peripheral, that would consider to be resource exhaustion, and that would throw an exception. For configure pin, same thing. All the pins are set to a very specific default when they boot up, which is input floating. I think that's okay to keep as a default, just because if you have multiple input pins, all with everything being input floating, there's no real harm in having 1,000. Besides having 1,000, wasting space, but there's no real harm in having 1,000 objects reading the same register. Like it's not performant. It's not a good idea. It's not efficient in terms of code size. But there's like no real what's the word I'm looking for? There's no race conditions really that could happen. Really shouldn't be. And even then, it's really just reading from a pack of register, like a register and bit masking. For the most part, the bus will manage the contention between different threads wanting to access the bus. So yeah, no, having the idea here is that if you configure your pin to something else, let's say into an alternative mode or into a SPI pin of some sort, and then some other pin comes in and says, I want to turn this into an I2C, it knows that there's something wrong here because it should only have converted it from an input floating to I2C. It should not have converted it from an SPI to I2C. That means something's still using it. This also means that drivers will need to remember which pins they use and will need to reset them after they are done using them, so in their destructors. But the cool thing about this is that after I made these changes, I was able to find quite a few bugs. Actually, in the STM project, there is the bitbang SPI, and then there's SPI. They use the same exact pins, understandably, because they were trying to use the same exact port. And there's like an if statement, and I'll actually show it later. You know what? Actually, I might even have it up right here. Yeah, I have it up here, although I have changed some things. Let's see. Yeah, here's the example. So we have the bitbang, and I'm doing some other funky stuff in here, just experimenting. But we create a bitbang SPI, and the pins are defined out here, meaning that they've already claimed the pin as being something other than an input. Technically, SIPO would be fine, but the sclock and copy would not be correct. So this actually crashes if you set all of the configure pin functions to throw an exception if they're not currently reset. So I was able to notice that. I was like, cool, that's useful information. Even though the SPI object never exists, at least I was able to find contention with other things that I had. So that happened. I think also I discovered some other situations in which the power on needs to be a little bit less specific. Like for GPIOs, I'm actually thinking about making a peripheral manager for each GPIO port so that we power on when that object for that port gets created and then power off when that port's object gets destructed. Versus having each one of the different output pin objects have to like manage, hey, is the output pin already set up? No, it's not. Okay, well, I should turn it on. And then all the other ones subsequently seeing that it's already turned on and ignoring it. So that's that. Oh, and then the hope here is that, I don't know what I was trying to say here, but basically, because construction of objects typically occurs, we want to kind of push people to do this early in the program. It should detect issues very soon after you flash. I think that's what I wanted to say, after a flash. So cool. Next up, we're going to go into relaxing ABI stability. Sorry, the order is a little off here, but platform packages and board packages. I've been thinking about. So I've actually been going through all of the like a couple of the readmes. I've actually updated the libhal, util, and armmcu readmes because they actually had a whole number of flaws and just mistakes and typos in them. And things I thought were probably useful to talk about. One of such things is actually, and actually I'm going to drop out of this so I can go into libhal. We're going to go straight to the top here. And one of the things that I want to show you is this. I've now added, and I probably should have made a section for this, but I want to add in semantic version explanations for every single one of our packages, so that people understand what each semantic version means. So, for example, if you know what semver is, you have three numbers: major, minor, and patch. Major is supposed to be for breaking changes. Minor is supposed to be for adding features, or for adding features. And then patch is meant for changing things like fixing bugs, but not for changing behavior. Usually, should be that way. So, I have decided that for libhal, the major change number will increment if there's an API break, an ABI break, or a significant, or just a behavioral change, one that would actually cause a change in behavior of the code. If we do a behavioral specification or like explain something a little bit deeper, but the intention is supposed to be around the same, we won't make a major change. But if we say something along the lines, well, let me explain this. I can show you what's written here. So yeah, an API break is basically a situation in which you've removed or changed something such that other code would break, or code that depends on libhal would break. So if we remove the SPI interface, that would be an API break, or removed any of the APIs for it. Because I bet every single one of them is being used currently. An ABI break is something that breaks the ABI of an object or interface. This is kind of held vague. I probably should bring in a link so that people can look at what kind of things constitute an ABI break. But for libhal specifically, the only real ABI breaks would be some sort of change to the parameters of a function, like a default parameter. Actually, I got to look into whether or not that actually causes such issues. One of them would be changing the return type of a function, any function. That's an API break. And rearranging the virtual APIs. If you do either one of those, you cause problems. I think adding in default parameters isn't exactly an issue, so I don't know if that's a problem, but that's a thing. And then a change in behavior would be something along the lines of, let's say we had a function called hello write, you give it hello world, and you have a callback. And before, you're supposed to call the callback after writing the message wherever you need to write it. If the parameter, if the documentation or the behavior of this becomes actually ignore that callback, then that's a significant enough of a issue that code that relied on that callback being called would break. So something to keep in mind. I want these to be all stable for the major number of libhal because it's so important that other libraries can depend on that. If they can depend on everything like this staying stable for a specific version, without having these three things be stable, it would be impossible for a hardware abstraction layer or really any abstraction layer to feasibly work. That's just how it is. Actually, I think in some cases it could work, but if we want to be able to utilize pre-built binaries and allow people to distribute their binaries everywhere and have libraries be built anywhere, I think this is a key thing for us to keep in mind. Unless we find some way to somehow get around that, but I think in general it's perfectly fine to keep this. Minor number changes if we add a new interface, API, or type into the public interface. Nothing too crazy there. And then patch changes, basically bug fixes that align behavior with what the API specify, improves performance, improves code size, something along those lines, but doesn't break or change anything like the above. And also anything that happens inside the experimental directory. It's experimental, we only make patch changes for those. If we make changes, but a patch change difference that affects the experimental directory could be significant. So keep that in mind if you use anything experimental. Assume that it will straight up break in the next version. Alrighty. Now, here's the reason why we are relaxing the ABI stability of platform packages. It really comes down to this. So let's talk about what it allows. It allows classes and drivers to rearrange the member fields as necessary. So another thing that could be an ABI break that's not useful for libhal, since all interfaces are pure interfaces in libhal. Let me double check. Yeah, that should be the case. So they don't have any member variables. They have virtual functions that you can't rearrange, but they don't have any member variables. I did consider the idea of pimple-like storage in each of the interfaces today, like an 8-byte or a 4-byte, 8-byte, 16-byte, 32 and 64-byte versions of all the different interfaces, and they would utilize that internal storage to hold their own members and everything else like that. And then drivers can use that blah, 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 blah. Basically, I've been thinking about a lot of this kind of stuff. And one of the things that I kind of disliked about keeping ABI stability is that once we put out a feature into libhal ARM MCU, it's kind of stuck that way. And the only thing we can really do is potentially change. We could swap out fields so long as the size stays the same, but we can't increase the size. And we can't also shrink the size either. Both of those would be problems. So I was thinking to myself, what do we lose by losing ABI stability? Stability. And the answer is actually nothing. It's actually a good idea to be ABI unstable, just so that it's a threat. So what does this prevent? Well, when you're using something that is ABI unstable between version releases, minor version releases, what it kind of indicates to you, and what we want to make sure we indicate to everyone else, is that library drivers or just device drivers that use libhal interfaces should never depend on a platform or board library. It would be absurd for an accelerometer class to invoke the micromod SPI API in order to acquire an SPI port so it can start doing stuff. You could do that, but now if the code isn't built for micromod, how does this even work? Where did that API go? You probably get a linker error actually. So, and if you did link it in, then that's just a more bloat that you don't need for maybe an application that doesn't even have a micromod board, that kind of thing. Same thing with if you make a dependency for a driver to take an LPC GPIO or output pin. Why would you couple your driver to that? And if it's that coupled, maybe it should already be in libhal ARM MCU. So by allowing us to say, hey, the ABI can actually change for any one of our objects, their format and structure could change at any time and place, it discourages developers from utilizing those classes inside their objects. They should stick with just the pointers to interfaces, and hopefully in the future we can come up with better pointer types that are a little safer and all of that. So that's pretty much what's happening with relaxing ABI stability with platform packages. And the same thing happens with board packages like micromod. If we swap out, basically the object sizes for things can change. That's pretty much that. All right, so next up, and pretty much the last item here, is this me contemplating, this is a thought experiment. I'm not changing anything, although I would this has some nice properties to it, but I've been thinking about a stack-only application. The idea is that main would call init would call application, and then your application would run from there. One of the issues that I have with how we do things currently is that main calls init returns, and then we call into application. The thing I don't like about this is that you need to somehow return out all of the objects that you want to use in the application in some way, shape, or form. You need to have them persist but beyond the function call. The way we do this now is we use static. And I don't like I'm cool with static in general. I don't have a particular problem with it. We use it for micromod. I think that's a fine solution. But I keep thinking about what consequences uh, forcing like developing around static kind of makes you do. And we've already experimented with it, and it works mostly fine. People will forget static in certain places, and then it'll give them faults. With the new resource optional design, people are able to find it as exceptions now versus seg faults, which is nicer. People's code terminates now because of that, so it's better. But it's still one of those things where I have no problem with the optional, but I am very curious as to, is there a way that we could ensure that the lifetimes for everything persists, or at least lasts as long as it needs to for the application to run? And then my brain a week ago thought, well, what if you just called the application from init? If you call it from there, then everything else you created in your stack will now be able to be allowed down further. Because you now have a top-down stack hierarchy, you don't have to worry about lifetimes as much. It just kind of goes downwards. Now, this is kind of cool, and I was getting really excited about it, but then I realized we hit a bit of a problem. What do you do when you hit conditionals? Like, if you have to make a choice between creating one object or another object, what could you do? And before I go there, I want to talk about, kind of go back to why I kind of like the stack-only applications. Now, I'll show what that was in a sec, but let's say that the application throws an exception, and nothing within the application knows how to handle it. Well, it comes back up to init, and init will have context into the various types of platform-specific exceptions and errors that could occur, and could even potentially know how to handle those errors. So, for example, if you get like a device not found, and it comes from a particular I2C, and you just know it's in the errata, that if you get one of these such errors, it means that you can reset things, do something along those lines. Maybe unwinding all the way up to init is a little bit extreme to do that, to solve that problem there. I know I wouldn't disagree with that. But if you at least had a solution, you maybe could apply it at that point. The other cool thing that happens is that if the exception propagates even further and goes out to main and kills out init, you will have, remember how I wanted to make configure pin also reset all the pins, and I wanted power on, power off. All the instructions would have to remember what the peripheral ID is so they could use it to power back off the device, such that by the time you've escaped init, everything should have been reverted as close to possible to what the system was like before you even ran into init. It can't ever be hermetic because there's going to be global variables that might exist somewhere that are set in an odd way. This would inspire us to try to stay away from global variables as much as possible outside of the global variables we don't have control over, which I would actually appreciate. I think that's a good design. I think that's a good way to develop things, and I would really love it if we could, to some degree, write code that aspires to put the system back to the setup that it was before. Because the cool thing about that is that maybe we could have a single main that can choose between different applications. Maybe that's a thing. And by making everything stack only, it means that you get all of the stack space for any application that you execute. So that sounds kind of neat to me. And it doesn't have to just be a init to application. Maybe it's init to application to another init. Maybe the application itself knows how to execute other applications. Maybe we want to also, run threads. Put each one of these in its own little thread. And we give it the init function for that particular thread, which then does all the initialization that it needs, and then also calls its own little application, which is basically its task to do for that particular thread. And if a thread were to throw an exception that reaches up to the top of the thread, you'd end up resetting and cleaning up all the resources there. So if you wanted to reinstate that thread again to maybe let it do its work again, it should be free and available to do so. These are all just ideas and things that I've been thinking about in order to make safer code, and I guess I'm gonna put out a couple others. I already mentioned something alternatives to pointers, passing those in. One of the ideas is to use or to consider something along the lines of standard polymorphic and standard indirect. Indirect is basically just a it's like a unique pointer, but it can do copies. And the copy, yeah, basically does copies. So basically it can copy itself, and when the indirect object basically gets destroyed, it will clean up the resources for that object. Unique pointer is cool, but it's mostly meant for ownership and cannot do copies. Polymorphic basically acts like a unique pointer type thing. Unique pointer is also polymorphic in nature. You could use it to, you can have a unique pointer, allocate for a type that's a derived type, and have its, you can keep a, how should I put this? Basically, if you had an output pin for LPC, you could pass it into a unique pointer of an output pin and it would still work. I've been thinking more and more about using those type of things. I don't know if they really fit. I'm still thinking about it, especially because I don't want to really manage dynamic memory allocation. If anything, I might put that into micromod. Have an API, maybe initialized platform requires you to pass in a block of memory that's on the stack, or actually it can be anywhere. And the drivers from the micromod are allocated using that memory. That way you can choose where you want that memory to be, and then you could have a little more control over the lifetime of your objects versus having them be static. I could see micromod's static stuff being a problem in the future. And then finally, I've been thinking about ways of detecting drivers that you've passed a pointer to, but then you've accidentally returned from a function, returned a driver from a function, and the object that you passed into it was a local variable and was now destroyed. There are like two ways to solve, like there's a lot of different ways to solve this. And in a way, it's basically me asking for a borrow checker. And I was thinking about like, okay, I've seen people implement like borrow checker like stuff in software. I was thinking of something along the lines of a like doubly linked list. Every time you create a reference to yourself, it just adds it to the doubly linked list. And if the original object is destroyed, what it does is, I've been thinking about this for a while, fatal types. I think I might have talked about this before. A fatal type is, let's say we have like an output pin, and it's an output pin for an LPC, but that object was destructed. We have a lot of references to that particular type. What should we do? What do we do with all of these pointer-like objects? And one idea that I've had is, what if you could redirect them? What if you could redirect them to something that would either throw an exception or just terminate the application? Just say, hey, this is it. Actually, I think terminating would just be the proper solution here. Basically, a panic. You violated something. So the idea is that you would kind of in place construct on top of the memory that held the original object a fatal object. And the fatal object has no memory, doesn't store any memory. All it has is a V table pointer to its functions. And all its functions do is call terminate the moment that you try to access them. That way, there's no checks that have to happen in the code. This all just kind of happens naturally. Drivers don't have to check to see if their types are fatal. Just simply trying to use them. If they are safe, will be safe. If they are not, it will panic. Yeah, just a couple of ideas of things that I think could make using polymorphism automatically type safe, or like automatically safe in C++, even if you have something along the lines of a resource leak of that sort. And the double linked list is just to hold an account of where all those different pointers are in the code, so that the original object, when it destructs, can basically iterate through all the other pointers that existed of it around and update them. That is one option. It has a bit of a cost to it. The hope is that the objects that you have die before that happens, and then you end up having not do much cleanup, or not much cleanup. There's also one other option, which is to revert back to a previous idea, which is that drivers should not be movable or copyable. If you can't move them and you can't copy them, you can't return them. Well, actually, technically you can still return them. Yeah, if you do RVO, return value optimization, you could technically still return them. I don't know if there's a way to stop something from being returned. There might be. I think if you delete a move constructor and the copy constructor, I don't think you can actually return them from something, even if RVO would technically allow it because the memory and storage was in the call site, not from the call. I think that happens. So basically, yeah, that would be the other solution. And I'm thinking about making that the right solution because it's easy, it's simple, and it prevents people from doing the wrong thing. But yeah, that's pretty much it. That's pretty much it for this month or for this, for the last 2 weeks or 3 weeks technically. So yeah, see you guys in 2 weeks.